Hello friends, let us try to solve this absolute value equation. The absolute value of 2 minus the absolute value of 3 minus x closed equal to absolute value of 2x minus 1 plus 3. If we try to solve this algebraically, we'll have to consider different cases. Okay, so looking at the equation, the different switching points can be marked on the number line, right, as being half and 3. 0 I've just indicated as the 0 on the number line, but the switching points are half and 3. So which means the different cases that I have to consider are x is less than equal to half, case 1. Case 2 is x is between half and 3, and case 3 is x is greater than equal to 3. These cases arise because you can look at the original question given, right? Absolute value of 3 minus x, so x will be a switching point, and absolute value of 2x minus 1. So if you equate 2x minus 1 to 0, it will give you the switching point x equal to half. Okay, so we can erase that part. So these are the three different cases then. So consider case 1, x is less than equal to half. So when x is less than equal to half, the absolute value of 2x minus 1 becomes actually 1 minus 2x, because x is less than half, so 2x is less than 1, so therefore absolute value of 2x minus 1 becomes 1 minus 2x. Also the absolute value of 3 minus x stays as 3 minus x, because x is very small compared to 3. So considering this, our equation becomes 2 minus 3 minus x equal to 1 minus 2x plus 3, which is the same as absolute value of x minus 1 equal to 4 minus 2x. Now what is absolute value of x minus 1 when x is less than half? It's going to be 1 minus x, because 1 is greater. Okay, so if we solve this, we get x equal to 3, which is not a solution because it does not lie in our assumed range. Our assumed range was x is less than half, and we get a solution x equal to 3. So therefore in this case, case 1, there is no solution. Similarly, we'll have to work with case 2. So let's erase this part to show you case 2. Oops, I just wanted to erase this part. Okay, yeah. Case 2. Case 2 is when x is greater than half but is less than 3. So what happens is the absolute value of 2x minus 1 is equal to 2x minus 1 in this case, because x is greater than half. However, the absolute value of 3 minus x stays as 3 minus x, because x is still less than 3. So our equation becomes absolute value of 2 minus 3 minus x equal to 2x minus 1 plus 3, which becomes the absolute value of x minus 1 equal to 2x plus 2. Now x is in this range. Okay, so how are we going to decide now what absolute value of x minus 1 is? We'll have to split this into two further cases, right? Two sub cases. One sub case is that x is greater than equal to half but is less than equal to 1, and the other sub case is that x is greater than equal to 1 but is less than equal to 3, and accordingly there will be the value of x minus 1. So okay, let's do it on the left hand side here. Okay, so sub case 1, when x is between half and 1, so what happens is in this sub case what happens is x is still less than 1, so absolute value of x minus 1 is actually 1 minus x. If that is the case, our equation becomes 1 minus x equal to 2x plus 2. Solution therefore is 3x equal to minus 1 or x equal to negative 1 by 3. This is not an acceptable solution because it does not lie in our assumed range again. Okay, so we have worked on case 1 and sub case 1 of case 2. Similarly, we can work on sub case 2 of case 2, then we can work on case 3. Okay, so you can try this out on your own. It's a long workout if you use this algebra. So there is another method. Oops. 1 second, I just clean this. Yeah, there is another method which we can use to solve this question, that is the graphical method. So let's try to do it that way, and let's see if we can do it in an easier way if we use graphical method. Okay, so we'll draw the xy axis. So we then try to draw the graphs of these two, right? The left hand side and the right hand side. Okay, so what is on the right hand side we have absolute value 2x minus 1. So absolute value 2x minus 1 can be rewritten as absolute value of 2 into x minus half, and 2 can be taken out because 2 is positive. So we have 2 times absolute value of x minus half. Absolute value x minus half is straightforward. It's the standard absolute value V-shape graph, but the vertex being at half this time. That has to be multiplied by 2, right, because we have a 2 here. Okay, so showing that by the green color, right, so that is absolute value of 2x minus 1, this curve. But what we want on the right hand side is absolute value of 2x minus 1 plus 3, so we have to go 3 up. So this is like our final graph. Okay, so that purple one is the right hand side, right, which is absolute value 2x minus 1 plus 3. Now okay, we'll draw the left hand side graph, but we also need to erase these other graphs which are not useful anymore. Just a second. Okay, yeah, we can erase this whole thing. Yeah, so on the left hand side what we have is we have absolute value 3 minus x, which is actually the same thing as absolute value x minus 3. So what is absolute value x minus 3? It is the standard V-shape absolute value graph but centered at 3. So this was half, and let's mark 3, 1, 2, 3. This is also supposed to be 3 because I added 3, right? So centered, so the absolute value x minus 3 centered at 3. Okay, so it will be something like this, and when it goes up it actually meets the 3 here. It doesn't exactly look like a 45-degree line, but that's because the scale of the x and y axis are different here, right? Because but we know that absolute value x minus 3, this curve, right, this curve that I am drawing here will cut the y axis at 3. So then this has then what we really want is minus x minus 3. Okay, so what is minus x minus 3? Yeah, let's try to go back, take it away and draw it on the other side because it's negative, so we'll draw it down. Okay, what we really want is minus absolute value x minus 3 and 2 minus that, right? That's what we want on the left hand side. So basically we are adding 2 to all this, which means that we'll take this curve up by 2 units. So it will be going through 1 like that and down. Okay, so if we label these points, this is 5. And finally what we actually want on the left hand side is the absolute value of that, absolute value of 2 minus absolute value x minus 3. So we just take the absolute value of the orange curve and we get the red curve, right? So wherever there is negative value we'll reflect that, and wherever there is positive value it will stay. So it becomes this W-shaped graph, the red one. So the red one is the left hand side, this blue one was the right hand side. As you can see, there can never be any intersection between the blue curve and the red curve, so there is no solution. So the graphical method also works just like the algebraic solution, which I was showing you. I did not show it completely, but even in the algebraic solution there will be there were total of 3 cases, and in the second and the third case there will be further 2 subcases. So there are total of 5 subcases to consider in the algebraic solution, all of which will give you no solution. Okay, so it was a long method, so we worked out using the graphical method, which is not such a long method, and it gives, and that also tells you that there is no solution, right? You can solve this equation graphically. Okay, thank you.